when we're talking about straight line motion, what a type of problem you'll see very often is a lot of times you have a particle moving back and forth along the x-axis. That's what they give you a lot of times. There is a particle moving back and forth along the x-axis. Sometimes they try to put it in context of an actual situation. It might be somebody riding a bike back and forth along a straight road. There's one that they gave, it's been several years ago now, and it was a squirrel going back and forth across like a windowsill or something. I can't remember what it was, or maybe it was like a wire, but it was a straight wire. Anyway, if you have something that's moving according to a specific pattern, you can show that with a position graph. So if you think about, let me think of a good straight line example. Let's say that you are drag racing, right? Because that's a good straight line example. NASCAR racing, not a good example because you're going around in circles and you've got more dimensions. So if you were like drag racing, so you pull up next to somebody at the light and they're challenging you, starting to rev the engine, and you got to take off. All right. You are going to take off, and if this is the case, if we're drag racing, then you just get further and further and further away from your initial point, right? You don't ever come back to it. You just get further and further and further away. If a drag race, what's the graph going to look like for that? What's my position going to look like? Nope. Nope. Probably not in most situations. So whenever you take off, you're not going as fast as you are like once you get up to speed, right? So you're not going as far. So it would be some sort of like concave up graph like that, right? Wait, or have I got this backwards? This is okay. This is okay. Yeah. Yeah. For position. I should have used this without thinking it through a little bit more. I should have just done a generic example. Is this right? Or is it the other way around? I'm thinking about velocity. Let's see. I'm pretty sure I know what velocity is supposed to look like. It should be concave down, the increasing position. I think we're okay here. There's a chance my position is not perfect on this one. I should have thought about it a little bit more. Now the velocity, since this graph is increasing, my velocity has to be positive the whole time, right? So that would mean velocity would be like our in this case, probably let's do hours and miles, right? The units are really what's most important. I might should have just not used a specific example. Without thinking through a little bit more. So that would give us our position graph. If we take the derivative of this, then this stays hours, but what are the units for my vertical axis here? Miles per hour, right? Which is velocity. Velocity is different than speed, right? What's the difference between velocity and speed? Okay, very good. velocity is speed and direction. In this case, when we're drag racing, we're going to boil that down to just positives and negatives, right? So positive is forward, negative is backwards. If you're drag racing, hopefully you're not going in the negatives any. Speed, it doesn't matter what direction you are going. So speed is just what we call like the magnitude of your velocity. It's like your absolute value of your velocity if you're looking for speed. So this is velocity, not speed. Although you can't tell the difference because it's positive in this case. If we had some negative velocity, we'd be able to tell the difference. So in this case, you're looking at like the slope of the graph. And this is the one I think I know what, like it should be positive, but I think it should look more like this. When you take off, your velocity is going to, like you can go from 0 to 20 a lot faster than you can go from 20 to 40. Or definitely like 0 to 60, you can do that faster than 60 to 100. Right? It takes you, once you're like get to the top end, it's going to take a little bit longer. This can still be compatible with that, I'm pretty sure. Yeah, this is still compatible with, I think I'm okay. Because this is still compatible because over here, your velocity is not increasing nearly as quickly, right? But your position is still growing faster and faster because if you're going 60 miles an hour, you're going a lot further distance than you were when you were on 20. So I think this is still okay. Now, the acceleration of this, what would our units here be? Miles per hour squared or miles per hour, right? And this is where you might see it turn into more of like a straight line. It depends a little. I'm not as certain about that one. Definitely you're increasing here, so it's definitely positive. Actually, no. For what I've drawn, this is increasing, so it's definitely positive, but my graph is concave down. So what would that tell me about the derivative? If this is concave down, I should be decreasing, actually. It might be more like this. That. We'll think more about the specifics of it in a minute. What I'm really looking for is what happens with those units. So, your position, they use different letters sometimes for position. Sometimes they'll call it X of T. Sometimes they call it S of T. They could use any letter they want, really, for that. Your velocity, they almost always use V, and it's going to be your X prime of T. And acceleration, they almost always use A. And you could call it V prime of T, or you could call it the second derivative of X prime, or of X of T. And typically they'll use T as your variable on these problems. Okay, so to find, like typically right now we will be given a position formula. Whenever we learn how to integrate, so next semester when we learn how to integrate, which means we can go backwards, like instead of taking a derivative, we'll have the derivative and we can go backwards up to the function above it. When we learn how to do that, they might actually give us the middle equation. But for right now, they're probably going to give us position most of the time. If we take the first derivative, that gives us velocity. If we take the second derivative, that gives us acceleration. Okay, so let's look at some examples. Okay, an object moves along a straight horizontal line so that at any time t from 0 to 9, its position is given by x of t equals 9 minus 3t plus t squared. So that's our position formula. What is the velocity of the particle at t equals 5? Is it moving to the left or right? Okay, so if we want velocity, what have we got to do? Take the derivative. If it is free response, what you need to do is you need to, I like to use the letter V because it reminds me that we're doing velocity here. But I'm going to say V of t equals x prime of t. It makes it very clear to the grader that you're taking the derivative here. This is especially helpful if you mess it up and you don't get the derivative right. They at least know what you were trying to do and can grade with you as you go versus not. So if I take this derivative, I'm just going to get negative 3 plus 2t. And they want at 5, so I'm going to do v of 5 equals negative 3 plus 2 times 5, which is negative 3 plus 10, so I will get 7. Okay. In this particular case, you're moving across the horizontal line. So think about the x-axis. Right would be positive, left would be negative in this case. So since our velocity is positive, then we are moving to the right. Okay, so we would say since v of 5 is greater than 0, or since velocity is positive at this point, the particle is moving to the right. At t equals 5. Occasionally they give you a vertical line. Positive would be up, negative would be down in that case, or you might have like the height of something, so positive is up, negative is down. But if your velocity is positive, particle is moving to the right. If your velocity is negative, particle is moving to the left. Okay. B says, what is the acceleration of the particle at t equals 5? Is the particle speeding up or slowing down? So this is going to be a type of question. It's super tricky sometimes. But yet there's like a formula that makes it very easy to know. It's just easy to forget. The acceleration of the particle, what do we need? Second derivative of our position, or we could just take the first derivative of our velocity. I'm going to say a of t equals, you can call it x double prime of t, you can call it v prime of t. Do something there to know that we're taking the derivative of what you had before. And what is our derivative there? Just 2, right? So a of 5 equals 2. Okay, so if our acceleration is positive, what do you think is happening, speeding up or slowing down? It's speeding up. But that assumption is only true because we're moving in the positive direction. Okay? So this to me is tricky to think about. So it's very easy to think about if we are driving a car and we are moving forward, positive direction, right? And our acceleration is positive. That means that not only are we going forward, we are going forward faster and faster and faster, right? We're accelerating. That's like in our vocabulary. It's what we think about. Okay. What's difficult to think about? Driving the car. This time, you're going backwards. Okay, so negative velocity. So if you have negative velocity and positive acceleration, are you speeding up or slowing down? Feels like it should be speeding up just because acceleration, if you have positive acceleration, you should be speeding up, but you are slowing down because speed does not have direction on it. So if you're going backwards, but your acceleration is positive, so like to think of it like with a table. What's happening here, your velocity, you're going backwards. So it is negative, but your acceleration is positive. So let's just do like something simple. Let's say the acceleration is 2, right? So if my acceleration is always 2, acceleration is the rate of change of velocity, right? So that would mean maybe my velocity was negative 10, but then it's negative 8, and then it's negative 6, and then it's negative 4, right? That's the situation you have whenever your velocity is negative, but your acceleration is positive. So your velocity is increasing, but what's your speed doing? The speed is the absolute value of your velocity. What's your speed doing here? You're going 10, 8, 6, 4. You're slowing down. Okay, so it's a situation that's easy to think about whenever velocity is positive and hard to picture, for me at least, whenever velocity is negative.
So like if the part A, if that was moving to the left and then we got the same number 2, we'd be slowing down.
Right, you'd be slowing down. Right. So there is a very simple sort of formula that you can boil this down to. So we'll make ourselves a note right here. If A of 5 and V of 5 have the same sign, the particle speeds up at t equals 5. And if A of 5 and V of 5 have opposite signs, the particle slows down. At t equals 5. So for our conclusion here, we would say since A of 5 and V of 5 are both positive, the particle speeds up at t equals 5. For me, it's difficult to kind of like think of that necessarily like, because we typically think of like always having forward velocity, not negative velocity. So it's kind of hard for me to picture it like actually happening. But it's a very simple rule. If they ask you for speeding up or slowing down, you need to look at velocity and acceleration, not just acceleration for that, which doesn't seem quite right, but it is. All right, so this one is a calculator active question. So if you have Desmos pulled up, we'll look at it. I'm going to pull it up here to, well, the regular Desmos. Okay, and we will type in that equation. F of x equals e to the square root of x minus 4x plus 5. It gives us this graph right here. That gives us the position of a particle moving along a straight line at time x for 0 to 20. Find the times from 0 to 20 at which the particle is at rest. So this is position. Okay, it is not velocity or acceleration, it is position. When is my particle going to be at rest? It's at that minimum point. Specifically because if you are at rest, what is your velocity? It is 0. And where would we have a velocity of 0? At a maximum or minimum where we have a horizontal tangent, right? So we could even, with Desmos, we could graph f prime of x. And you'll notice right here, you can look at the minimum point and, well, move this over. Not that. Gracious. Here's our minimum point. It's 10.63859. If we look at our x-intercept right here, it's 10.68359. Right, it's where our velocity is 0. So it would be 10.639. They don't give units on this, so you can leave them off. They tell you for this one, they use an x for time, so you would say x equals 10.639. And I would, like, if you have to give a reason, I'd say because f prime of x equals 0. Oh, no, don't do f prime of x. Do f prime of 10.639 equals 0. That tells us the derivative is 0 at that point. Okay. B says, what's the position of the particle at x equals 0? So if we're looking for the position of the particle here, I'm just looking for like where I cross that x-axis. Oh gosh, this is a tricky graph right here because it cuts back down a little bit. It's 0, 6. I also could just, actually I could just do this. I could just do f of 0, right? 6 for that. So we get 6 for that. Maybe we should put f of 0 equals 6. What do I need to do to find the position at 20? F of 20. And f of 20 is going to be 12.5435. Let's just keep that whole number in our calculator. Okay. D says, what is the total distance that the particle traveled on the interval for 0 to 20? What should we do? So like, just look right over here where x equals 20, which is f of 20. Okay, so our position, where did this particle start at time equals 0? Where did it start? 6. Where did it end up at 20? Okay, so what is an idea you might have? The idea is that you would subtract. And sometimes that works. It does not work on this problem. So that will work if you're going in one direction the whole time. So I always use this example for this class. Whenever you see this phrase right here, total distance, you got to keep in mind that if you go in the wrong direction, it still counts as distance, right? So if you leave my room, let's pretend the bathrooms are both on this hall. That one you got to go around the corner a little bit, but not much. Let's pretend both of the bathrooms are on this hall, right? If you go out of my room and you walk down to that bathroom and they're cleaning it and you can't use that bathroom and you have to walk back to this bathroom over here, then your displacement from my classroom is the distance from my classroom to the bathroom down here, right? That's what we would get if we subtracted 12.543 and 6. Like, we subtract those two values, right? So it'd be 6.543. That's your displacement. But is that how far you walked? You walked further because you went in the wrong direction first, right? So when you see total distance, you have to consider the direction that the particle was traveling. Okay? So here, whenever I'm looking at my position up to this point, is your velocity positive or negative? If this graph is decreasing, my velocity is negative, right? Or you can look at the graph of f prime. That might be, right? If I look at the graph of f prime is below the x-axis here. Actually, this one's a little bit of a tricky problem because there is like this little tiny piece right here. It's not going to make much difference. But you're walking, like you're going in the negative direction for this time period because your velocity is negative. That's like when you're walking to the wrong bathroom and back, right? And then you switch to positive direction here and you walk for, that amount of time. So what you're going to have to do for this is you have to consider all the like critical points of this graph, right? So this one's a little tricky because it does have an x-intercept at 0.02086. It's probably not the best graph I could have given. So we know f of 0, f of 0 was 6. That's where we started from. If I do f of 0.02086, let's see where that is at. So I'm going to do f of 0.02086. I get 6.0719 there, right? So actually there was you took like a step towards that bathroom and then you decide, nope, I'm going to this one instead, right? And so you're going to go in the negative direction this time until you get to 10.69639. Let's see if we got more decimal places. Let us copy that. Yeah. So f of that number. So at 10 point something minutes, or however long this is, seconds maybe, 6, 3, 8, 5, 9, I get negative 11.460888. Yes.
So, why are we looking at f prime instead of f?
So right now I'm looking at f prime to tell where I have critical points. So where my velocity was 0, because that's where I switched from going like left to right, or the right direction, wrong direction. But I'm not using f prime when I type this in. I'm using f. So these are giving me like my position at those points there. So I'm using f prime to find my values, but I'm plugging into f to figure out where I was at. Okay. My last one would be f of 20, and that we've already found it's 12.543512. So what we've got to do is figure out how far we walked, no matter what direction it was. So from here to here, you just went 0.0719407 units, right? Just that tiny little bit. That's like your one step in the right direction you took before you said, nah, I'm going to this one instead, right? Then, from here, we don't care about signs, right? So we just want to know how far it was from positive 60719.407 to negative 11.406. So we're going to subtract those two. So we'll take this number and subtract this negative number, which is actually like adding it, right? And we'll get 17.5328. And then we got to know how far it was from here to here. I think I need to put F20 up here so I can copy and paste that number too. So we would take this number and subtract this number, and we get 24.0044. And so we would need to add all those together. So we would have the 0.71 here, have this number, and this number. And I get 41.609. Units, we don't know how far it is. Now, if you walk in one direction the whole time, then all you really got to do is subtract your position at those 2 points. But if you change direction, then you've got to consider this as well. Questions on that? Let's look at some more. So, for example 3, a particle is traveling on the x-axis, has position x of t at time t. The graph of the particle's velocity is shown below from 0 to 5. Which of the following expressions gives the total, or that shouldn't say which of the following, it should say right and expression that gives the total distance traveled by the particle over the time t 0 less than or equal to t less than or equal to 5. All right, so first of all, are we looking at position? No, we're looking at velocity. So when I see the velocity, right, if it is positive, what does that tell me about position, or let's see, it's x of t, position x of t? Increasing, right? If I've got negative, decreasing. We could also think of increasing as the right or positive direction, right? And this decreasing as the left or negative direction. All right, so whenever I'm thinking about what this particle is doing, for this part of the graph, which direction am I going? Or is the particle going? It's going to the right. And for this part of the graph, which direction? Left. So right here and left here. Now, they do not tell us what the values are here. So we're just writing an expression using x of t or v of t. So what I would need to think about is I would need to think about, like I did on the last problem, I would need to know x of 0. This would be my position at t equals 0, right? I would need to know x of 2. That would be position at x equals 2. That's where I change direction. I change from going from right to left. And I would need to know x of 5, where I end up at. Okay. Now, there's a couple ways that you could do this. Whenever I'm finding the difference between these two, and the difference between these two, one of the easiest options is, so when we're talking about like the difference in the distance, when they're asking for total distance, we don't care whether it's positive or negative, right? What's a way we can just like get rid of the negative if there is a negative? Absolute value just gets rid of a negative, right? So if it's an option, your best bet is just to say this is the absolute value of x of 0 minus x of 2. And this is the absolute value of x of 2 minus x of 5. So this originally was a calculator active question, so not a multiple choice question, so there were answer choices. So one option that we could have is we could say x of 0, absolute value of x of 0 minus x of 2 plus the absolute value of x of 2 minus x of 5. Does it matter if I do x of 0 minus x of 2 or x of 2 minus x of 0? If I've got absolute value bars, it doesn't matter because it's going to, if I accidentally get the negative, it's just going to wash it away with the absolute value bars. So if that's an option, that's the best way to do it because you just, I do this a lot when I'm using the calculator. I get a negative number. I know it really wasn't supposed to be negative. I just make it positive, right? That's what the absolute value bars are doing for us there. But let's say that there's no option with absolute value bars. All right, so, or without absolute value. Okay, let's think of it again. We got x of 0, x of 2, x of 5. Okay, so for this one right here, if we want it to be positive, that means we got to put the biggest value first. Which one's bigger, x of 2 or x of 0? Which direction are we going from 0 to 2? Right. So our position should be getting bigger, right? So it would be x of 2 minus x of 0. That would give us a positive number, right? But what about from 2 to 5? Which direction do we go from 2 to 5? We go back left. So 5 is going to be smaller than x of 2. So we would do x of 2 minus x of 5. That would give us a positive value. If absolute value bars are an option, you don't have to think about it. You just subtract and put the absolute value bars there. But I think the question did not have absolute value bars, if I'm remembering correctly, on the one like this. So our answer could also be x of 2 minus x of 0 plus x of 2 minus x of 5. There. For that. So these are both options in this case. Questions? All right. Let's see. Our next one is a calculator active. So let's type this one. Is it calculator active? Yeah, it's calculator active. Because we wouldn't be able to find that. So it's calculator active. A lot of these will be calculator active, or they'll give you like a graph or something for it. So I'm gonna do v of x because I think let's try it with v of t. Let's see if it works. Negative 2t plus 20 square root t plus 3 plus 8. Okay, it'll graph it. Let's see if it'll do v prime of t. Okay, it does not like to do derivatives if you use t's. So let's change it to an x. It can do a derivative if you use an x. Okay, so this question asks us about when the particle is furthest to the right. And it gives us for any time greater than or equal to 0. So if we wanted to, we could go over here on the end of this and do squiggly brackets and say x is greater than or equal to 0. So it doesn't even show us parts that don't work here. So when I'm looking at this graph, I need to know when the particle is furthest to the right. What do you think? It's not the maximum. Well, hold on. No. I'm thinking, yeah, it's not the maximum of this, because this is not position. This is not position. This is velocity this time. So, if this was position, you would be correct. It would be this highest point that it reaches right here. That'd be furthest to the right, because it'd be furthest away. But this is velocity. So we don't know where the position is. But if we're thinking about velocity, we're thinking about v of t, right? If we have v of t is positive, that tells us that we are moving to the right. And if we have v of t as negative, we are moving to the left. So we're thinking not like as this being the graph, but this is our velocity graph. So where do we switch from left to right or right to left? Right here at 110.56854, right? So, and in this particular case, this graph only switches one time, right? So if we made like a sine line for this, v of t, and we're starting at 0 because that's all we care about, and then at 100.56854. Our velocity is positive here, our velocity is negative here, and continues to be negative for all of eternity, right? So that tells us that our particle went to the right from 0 to 100.568, and then to the left for everything after that. So when did it end up being furthest to the right? 100.56854, because it gone as far right as it was going to go, and then it switched back to left for that. So So we would say since I would probably say it this way. Since v of t is positive for 0 to 100.5685. The particle 568, yeah. Particle, oh wait, 110. Yes, thank you. I've messed it up the whole time. Thank you. I heard some murmurings about things. All right, so since it's positive for this interval, the particle travels to the right during this time interval. Then for 110.5, oh gosh, where I changed it, it's, okay, what was it? 110.5685. So 110.5685 to infinity, the particle travels to the left, or the velocity is negative, and the particle travels to the left. Therefore, the particle is furthest to the right. At t equals 110.5685. Now, if you had like more than one switch, then they would have had to give you the original function so that you could plug in and check which one it actually was. But in this case, there's only one time it switches from right to left, so you can know for sure when it would be. I don't think so. This sort of helps me like organize my thoughts a little bit, but as long as you explain it in your writing, I think you could answer this one just with the writing. There. All right, let's see. We don't have, we should do 5. I feel like 6 is more important though. Okay, so, I think this is is this one calculator in it? It wouldn't be so bad. Oh, wow, look at this graph. That's crazy. Alright, this says that x is greater than 1/2. Or t is greater than 1/2. Oh. Why is it not? Oh, yeah, I gotta do squiggle brackets, thank you. Okay. Alright, so we're looking at this graph here. Particle moves along the y-axis so that its position at time t is given by this, I don't know, maybe this was calculator inactive. I guess it is, isn't it? I think it is. Okay, we're going to do it. We can do it. All right, this one's calculator inactive. So we got to take the derivative of this. I would write this way first. This is sine of t to the negative 1 squared. Okay, so this is position. I need to take the derivative for velocity. So I would write it this way, y prime of t, and then I would call it v of t because I tend to use v's for velocity to help me remember what I'm thinking of. What have I got to use to take this derivative? Give me a chain. There's also a product for this because you've got something with a variable times other stuff with a variable. So you got to use a product rule with a chain rule inside of it. So it's going to be t times the derivative of this stuff here, which is going to be 2 sine of t to the negative 1 to the first power times, this is a triple chain rule. So it is cosine of t to the negative 1. And then I got to take the derivative of the t to the negative 1, which is going to give me negative 1t to the negative 2. And it feels like you should be done, but you are not, because you now have to do the other part of the product rule. So you've got sine of t to the negative 1 squared times the derivative of t, which is just 1. Okay, so what I would do for this is I would clean it up a little bit. It is done right here, but they are asking you a part B, so I would clean it up a little bit. So I would, I'd get rid of negative exponents and deal with that a little bit. So I've got 2t sine of 1 over t cosine of 1 over t. That'll make this 2 negative. And then I've got t to the negative 2 right here, which is means this is like over t squared. One of those t's right there will cancel. And then I'll have plus, I'm going to leave it written like this because I think it's a little easier. I'm going to put that as 1 over t there. That. So is it okay with you guys if I just erase this t right here and that to make it look a little prettier so I don't have to rewrite that whole thing? There might be more that you could do. I'm not going to mess with it right now, though. I'm just going to leave it. So, at time t equals 3 over pi, what is the particle moving toward the origin or away from the origin? Give a reason for your answer. So, if velocity is positive or negative, it tells me whether I'm moving right or left. Okay? Is it going to tell me whether I'm moving towards the origin or away from the origin? It's not, because I got to know where I'm starting from, right? So this is a little bit like a speed situation. You need to know your position to know where you're starting out at, and then you need to know whether you're moving left or right. So you are going to have to find y of 3 over pi first. So y of 3 over pi is going to be 3 over pi times, I'm going to write it this way, sine of 1 over 3 over pi squared. What is 1 over 3 over pi? It is just pi over 3, right? We're going to see that come up several times. So we got 3 divided by pi, and then we got sine of pi over 3 squared. What is sine of pi over 3? Unit circle. Okay, it's your root 3 over 2. So I got 3 over pi, and then I've got root 3 over 2 squared. Which, if I want to keep going, is going to give me 3 over pi times 3 over 4, which will give me 9 over 4 pi. Honestly, you could stop earlier. What you really care about is where you're at. So we're at 9 over 4 pi. What's most important here is if this is 0, I'm somewhere over here on the right side. Okay? So I'm beginning on the right side of the origin. Here's my particle. It is the y-axis. Let me draw it like it's supposed to be. It's the y-axis and not the x-axis. So y-axis, here's 0. I'm at above. Right here is 9 over 4 pi. That's my position. That's where I'm starting at. So now I need to know velocity. And we are out of time. And I had already typed this into Desmos. So I'm just going to find f prime of 3 over pi. I'm only doing this because we're out of time. And don't have time to do that. So our velocity of 3 over pi is negative 0.1568. Alright, so if I have negative velocity, which direction would I be headed? Up or down? Down. Right, so am I headed towards the origin or away from the origin? Towards the origin. So since y of 3 over pi is greater than 0 and velocity of 3 over pi is less than 0, the particle moves towards the origin. At t equals 3 over pi. So your assignment is going to be a